All right, let's begin. Hello, everyone. Hello. That's better. How many people from Oslo are here? Any people from Oslo? Oh, nice. So this is becoming my tradition. I want to take a photo of us, but I need a favor from you. I want you to do a crazy move while I'm taking the photo, please. And here we go. All right, come on. 1, 2, 3. Thank you. I will share this later. Thank you so much for coming along. We're going to talk about macro frontends today, but before I jump into the topic, it's a lovely city. I love your city. It's been magnificent so far for me, especially this is my first time in Oslo. I've been a couple of NDCs, but this one by far is the most exciting and scariest. So if you see me stumble upon something, please forgive me. So macro frontends or macro apps are basically it's not a framework, it's not a library, it's a technique. It's a way that allows you to implement to structure your front end in a way where it gives you all the goodness of microservices in the front end world. However, when it comes to statistics, it's not that popular. And there is a reason for it. It's way damn hard to implement. There are many ways of implementing macro frontends, some of which we go through today, but the fact that it's not that widespread, it's because many teams have implemented in many ways, some of which are successful, some of which are not. So they had to roll back to the previous versions of their system. But hopefully at the end of today, you will be motivated enough to go and explore the last option, not the middle ones. So let's see what's on the agenda today. We're going to go through a short intro, a quick intro of what it is. Then we will have a look at core ideas behind macro frontend or macro apps. Then I will introduce you to Ali and her team and what issue they were facing for the product, which trials they did try, and what are some of those ways, and their pros and cons of each of those ways. And the final solution, which is really the most important bit for this talk and also in the macro frontend world. Before we go into the talk, you probably should know me first. So my name is Yaser. I'm a lead consultant at Redify, a consultancy back in Australia. I was expecting a bit of chuckle, but that's fine. It's far, far away. It's been crazy coming here, but it's totally worth it. You can find me at Twitter, Yas Hint. I've also got my own blog, and I've started to cross-post my blogs on dev community, which has been taking off pretty cool, so check that out. A disclaimer, I absolutely love monolith, but a good monolith. In fact, I believe that if you can't write a good monolith, you wouldn't be successful implementing macro frontends. Martin Fowler has a quote about microservices. He says, if your system is not complex enough to manage as a monolith, don't even consider microservices. I've done some manipulation to this code, and this is my version. If you can't vertically slice your system to be able to have isolated apps from data store through the front end, it's probably not a good idea to move to macro frontends because it just makes stuff more complex. So what are the core ideas behind macro frontend? The first one is development speed. You want to deliver features or fix bugs really, really fast. You don't want to, for example, wait for a deployment, I don't know, every quarter or something to be able to deliver a new feature. So this is the very important one. Next bit you want is team autonomy. You want your team to be autonomous, to be able to move at their own pace, to be able to develop at their own speed, and also deploy at their own pace. This is very important. It has to be customer focused. You don't want to add something which doesn't add value to your end users. You don't want to implement something, you don't want to spend time on implementing something which doesn't add value to your customers. So it has to be customer focused. And one of the reasons why micro frontend help the customers at the end of the journey is that it allows you to deliver all of those features to the customers really fast and in isolation, which we'll see. And the last one is each team should be able to pick their own technology or tech stack to implement whatever they're doing. They wouldn't be confined to a particular library or a framework to be able to operate. They can choose whatever they want. However, as we all know, there are heaps of many different libraries and frameworks in the front-end world. As David said before, one of which probably has been born 5 minutes ago. You have to check it out. But the fact that you can do it, it doesn't mean you should do it. And we'll see where it works and where it doesn't work. So I want to introduce Ali to you. She is a product owner in a company. This is all imaginary, by the way. Don't go look it up. It doesn't exist. She is running a product for a car dealership with her team, which is called Carzilla. I just made that up. If there is a company out there with this name, disclaimer, this is not that. It's completely made up. So what's happening here with Ali and her team is they have this product. People can come in, search for a car, and then they can order that car through the same web app. They can do the payments even, or get, for example, a car loan, and then go through the whole process from the same app. But the problem was they were having like one dealership, everything was fine. They started to open up more dealerships, and then things started to slow down. They had all sort of requests from all sort of customers. They also had partnership with other dealerships, and it just got worse and worse. So what was the issue? The issue was they had a pretty basic 3-layered structure monolith. Nothing very special about it. It was like a data store, a business layer, and a front end. But fixing a bug or adding a new feature took probably about 1 month to be able to deliver that process, including testing and user testing and deployment. So she thought, no, we're not going to do that. She went and searched, and they came up collectively with a set of criteria they wanted to meet for their product. And here are those criteria. So with the current setup, they didn't have any team ownership. They couldn't develop or deploy independently. They couldn't run independently, and so on and so forth. But they had some benefits, like the corporate identity implementation was fairly easy because it was the same app. Sharing state wasn't a problem. Smooth user actions, yeah, it was the same app. Nothing special about it. Native support was good too. But was it enough? No. They needed to do better than this. So they went, Googled, they found the term microservices. They became interested. They went and tried to implement microservices. So instead of having one giant team working in the same product, they started to break up those teams into smaller teams, every team dedicated to a particular feature. So they had the order team, search team, inventory, payment, order, whatever. However, when it came to front end, it was all the same. It was the same monolith. Every new deployment would result to the same result as before. It was a bit faster because each microservice could deploy independently, but at the end of the day, they all had to wait for the front end. So front end was the bottleneck. So in terms of criteria, nothing happened. Everything was the same. Although they had actually a good structure to move to the micro front end world. So they thought, okay, let's set up a vision and move toward that vision. And this is what they had in mind. So they wanted each team to own that piece completely, from all the way down to the data store to the front end. Every team was responsible for delivering that particular feature. If a bug was raised, if a feature request was coming, they would know which team is responsible. Everything was triaged pretty fast. Bug fixes were deploying pretty fast. So this is the vision they wanted to go. Now, why this vision works is basically comes to these two sentences. If you want to go fast, you have to go alone. So every individual team is responsible for that particular feature, which means they can move pretty fast. But if you want to go far, if you want to add more features to the same product, all these teams have to work together. So that's the next bit of puzzle. So although every team was responsible, all of the teams needed to collaborate together to be able to deliver the same product. So they started their first attempt. They separated those apps through to the front end as well. And they started to use hyperlinks to link those apps. So they were completely separate apps, deployed separately, run separately, and they were all having links. And it's pretty simple, basically. You had a hyperlink in a page, it will redirect you to somewhere else. Now, that was the first try. It wasn't bad because that gave them some structure. They gave them team autonomy. They could develop and deploy independently. But it wasn't fast loading. Every link that user clicked will result in the whole app to be reloaded. So it wasn't really that fast. And also they lost ability to implement the corporate identity properly. They had to use some hacks to get that working. Sharing state was basically through URL, and that wasn't ideal. They couldn't do modular, and this modular is basically ES6 module implementation, by the way. And user interaction wasn't that smooth. User had to wait for the whole app to reload it every time they clicked on a link. But native support was still there. So they looked back, said, nah, we're not going to happy with this. We will have to do something else. So they went and explored other options to implement the same thing in different ways. And there are a few options, as I mentioned before. You can have build time integration for all of those separate apps. You can have client-side or server-side integration at runtime. So instead of using build time, you do it at runtime, either on the client side or on the server side. Some of the big companies who are following this approach, like one of these approaches are like Amazon, Zalando, HelloFresh, and AutoSCAD24. They are probably the first companies who tried some of these approaches. And if you go have a look at they've got blog posts about their experience, and they share their mistakes and what happened and how they got where they are today. So it's pretty amazing. Check it out. But let's go back to the build time. Let's see what the build time looks like. At the end of the day, there are many ways to do it, but the most elegant way is probably using NPM package. So every app will produce an NPM package. It will add as a dependency to something else. It can be another app, or it can be an umbrella like an app shell, which then puts together all of these. And then you will basically build everything into the same app, deliver it to the client. Seems easy. It's fairly easy to implement. You can use it through Webpack, Rollup, whatever the bundling you can use. And the experience is same as before that you with the monolith, but this time the teams are separate. So every team is working on their own product, part of the product. So when it came back to the criteria, they had some sort of team ownership, but they had to collaborate through one team at the end, which was the umbrella or the meta app. They could develop independently to some level, but they lost the ability to run independently because it was all the same app again. And then deployments was again through the app shell, so they had to wait for everything to again deploy everything together. And fast loading, everything was bundled, and they had all sort of technologies implemented, React, Vue, and then the result bundle was like so bigger than the monolith before. So it wasn't really fast. But they gained a couple of things that they lost through the previous experience. So all of these resulted in them being not happy with this approach anyway. They said, okay, we're going to try something else. So they moved to server-side include, server-side composition. Server-side composition is possible with two major ways. There are many ways, but the two major ones are server-side includes, which is not something new. In fact, I found that reference in a book which is published at 2000, so it's pretty old. And it's nothing special. You have some tags in your markup. When the client sends a request to that particular page, the server looks up these tags. It knows how to get that particular app or the particular resource and replaces it with this tag, sends it back to the browser. And that's how it works. But it's pretty slow because the server has to look up all the current markup plus the linked markups and then so on and so forth. So this process takes a bit of time to do that. A better way to do this is through edge-side includes. And by edge-side, we don't mean browser. Edge-side is like a server which is responsible for answering the browser at the edge, which can be a CDN server or Nginx. And then that server knows where to get, for example, the other apps from other places. So if you have a markup, for example, which has a reference to search, it knows that it has to get it from the search server, replace it, and then send it back to the client. So it's a bit more elegant because all of those apps can run independently, whereas the server-side includes, it's just one server running everything. So it gives a bit more flexibility in terms of running and deploying independently, but it has the same problem. Loading is not that fast. Loading takes a bit of time because this edge-side server needs to parse all of those markups, and all of those individual apps can actually have tags which need to be parsed again and fetched again from somewhere else. So when it comes to criteria, yeah, they had team ownership, they could run and deploy independently. It wasn't fast loading again, we mentioned this before, but they had corporate identity because at the end of the day it was at the same under the same app on the client side, so they could implement some sort of corporate identity. Sharing state wasn't that hard anymore. They could really share a state from the client side through the server side as well. But the user interactions weren't that smooth anymore. User had to wait for the edge server to go and fetch stuff and then come back. So they said, okay, if we lack still, the most important parts are about customer, or about end user. So what we can do to improve that bit? So they moved to client composition, client-side composition. And client-side composition is available through two ways, basically. You can do iframes. Who here loves iframes? Everyone loves iframes. I hate them. But iframes are ideal for isolated apps. If you have isolated apps and you want to run them in the same page, iframes are the best. But they have some, basically, drawbacks. Search engine optimization is not that good. Security stuff, clickjacking, all sort of different issues which comes with iframes, most of which can be fixed, but then it's additional work, so you don't want to do that. And then when it comes to criteria, again, you miss a bunch of stuff which you don't want to miss. So instead of going through this way and using iframes, they said, okay, let's try the next one. And this is the most important part of this talk, through web components. So web components gives you ability to make your app as a component and then reuse that component everywhere else you want to. Communication with web components is pretty easy, just normal attributes. In fact, using web components gives you ability to create reusable components because you can simply say, okay, I'll have this search here. I can reuse this search in this app and that app and whatever. Web components are basically around 4 technology or maybe concepts. The first one is custom elements. And custom elements are just basically an HTML element which are derived from the main HTML element, the actual spec, but you can customize them. So you can have a custom HTML template as we see here. You can use ES6 modules to deliver that particular piece of code. Or the most important part is you can use Shadow DOM which gives you isolation. So every component has its own isolation inside DOM, which means that it can't affect any other place. So instead, in terms of, for example, CSS, it will be safe to use it even if you have separate CSS attributes and classes with the same name. So they wouldn't affect anywhere else. The API, it's pretty straightforward. So you can use TypeScript or even normal JavaScript. The recommendation is to use TypeScript because it gives you types, so you can actually know what methods and whatnot is possible through the API. You extend HTML element, which is the base class for all the HTML elements. And then you can have a constructor, which you call the super, to initialize the actual HTML element. And then you basically attach to the shadow DOM, which gives you a shadow root, which then you can use to replace your template inside it. So anything that you have, it's basically inside that shadow root. You can also ignore this. You can have your web components to be outside of shadow DOM, but that's not really recommended. Then you use the custom elements of window object in JavaScript to define your element with a name and this class. And then you just include the JavaScript file, the result of the bundle, and then use that tag. It's pretty straightforward. There are, however, some other methods which helps you, because if you want to have all of those benefits, sharing state, authentication, whatnot, you have to be able to pass the attributes into the web component and expect some changes. So imagine that in the search app, the user is always changing the search term, but if you want to recommend something like the Inspire team or recommending some, for example, accessories for different cars, if the car changes in the search result, you want to reflect that into the, for example, the other app. So the suggestions are based on the current cars which are appearing on the search result. So that's how you do it through the attribute change callback, for example. Or if you want to trigger an HTTP request to get some data from, for example, a backend service, you can use the connected callback. And that's when your node is attached to DOM, or disconnected callback if you want to clean up some stuff. So it's a powerful API, definitely look it up. But this talk is not about just web components. We are basically fitting this picture, this concept into a bigger picture. How web components help you with the macro frontend. Web components by themselves are not enough though. We still need something like app shell, which we mentioned before, to glue everything together. So imagine an app which has a header, a footer, it has login, for example, functionality. It has, I don't know, menu items where they probably switch the view, they load a different route. All of these are handled by the app shell. An app shell knows where to get, for example, a particular web component from. So if you are, for example, exposing your web component through an NPM package, the app shell knows where to get it. Or if you just simply are hosting a file on a live server, which then needs to be fetched, also app shell knows about it, which we'll demo shortly. But people are not really using vanilla JavaScript these days. They might probably use a framework, one of the major ones, or there are some people still using jQuery, for example, or all sort of different libraries and technologies. So let's have a look at the framework support. As of today, Angular has Angular elements, which is a way exposes a web component. So you can have a piece of logic, an Angular app or a mini app, and expose it through as a web component, which can be used later on in any other app. I've got a blog post about having a React app as a web component inside Angular and vice versa, using these techniques. Vue has its own way using Vue CLI, so you can actually write a web component through Vue CLI. It's pretty easy, very, very straightforward. React, unfortunately, doesn't have anything built in. Create React app doesn't support it, but there are community solutions you can use, or you can do it manually. It's very, very easy. I'll show you in a demo shortly. So if we went with this implementation, what do we get? We get basically everything. All those criteria will be met. It's very, very exciting that we can do it as of today, because previously the browser support for web component wasn't really there. But today, major browsers all support web components. So let's have a look at a demo. I think just to make this simple, let me just duplicate my display. That's probably better. So I've got an app here which consists of 3 different apps. So I've got the container or the wrapper or the app shell, and then an Angular app and a React app. And the app shell basically fetches these, which are exposed as web components, forms it into the same app. Now, if you want to, let's see it in action, and then we go through the code and explain what's happening. So let's go here. Let's start this one. Let's go through this one. So these are 3 completely isolated apps, which can be used standalone. I'll show you how. But we just need this one. So this is our app shell. It's a very simple app. You just type your name. That name is passed as attributes to those child apps which are running independently, and then they can react to it. So you can actually send messages back and forth through all of those components. That's how you do communications between all of those components if you want to update them, which are using the attribute change callback for that. So I can change this, for example, to something else, I don't know, and then tell the components about it. And then it gets updated here. Now the Angular app for some reason hasn't started up. Let me just check that. Yeah, it seems to be working. Yeah, seems to be working. Let me just refresh this. All right, there we go. So if I update this to something else, and then I can reflect it, it will reflect inside those components, which are completely separate apps. And by that we mean, so I've gone and created a index.html file for all of those, so you can run them independently. So if I click on Angular app, it will load just the Angular app, which is a component inside its own app. So if you want to run tests on that particular app independently, you could potentially do that. If you want to run that app independently and use it in multiple places, you could potentially do that. That's the power of web components, and how can we help you? So let's go through code. Let's start with the app shell. App shell is pretty straightforward. It's just a normal HTML page which has a bunch of styles, CSS, JavaScript, and then sorry? Oh, the font? Yeah, sure. Let me just bring up font. It's too big. Just close that. And that should do it. Actually, we don't need that. Just make this full screen. Is that enough? Readable enough? All right, cool. So what do we have here? We have a script tag, which is basically a function which communicates with the components. And then we have these 2 scripts which are exposed through their respective servers. So I'm running 3 apps runtime, and each app is exposing their relevant JavaScript file, which I'm including here. So these are the separate apps we just talked about. You will need the web components custom elements ES5 adapter, if you want to have backward compatibility with IE 11, for example, who wants that? Some people. And if you're doing, for example, let me just go through here. So if you're doing messaging, you will probably have to instantiate those components and then pass a message to it. So this particular function here is getting an element from the DOM, which is like a div, placeholder div I've put in the HTML. It is then creating the React. Basically, it's setting a bunch of attributes like the name, and it then changes the event handler. It just adds an event handler to it. And an event listener, which then you can just say, for example, this is what I want to do when that particular event is fired. And same thing for here for basically React. This is the container. So it gets that div, the container div. So basically, if you remember that custom elements.define method where we defined before, we had a tag name and a class. This particular create element, document the create element, is getting that particular tag name which is registered using custom elements. So when we say create element, React element, it will instantiate a new instance of that component and gives us an instance. And then here we get the container, which is the React container in this example. We remove all the childs because we don't want to duplicate that component in there, which also triggers the disconnect callback, if you remember from those methods. And then we add this new child to it. So it's fairly straightforward. Same thing with Angular. So we create a new Angular component in this instance and do the same for it. And then attach it to that DOM node. And this is basically what we get from that particular page. So this is an app shell. It doesn't have anything to do with any of those components. This is just gluing everything together. It's a central app. So the good thing about this approach is that if you don't want your, for example, if you have your search in the main page, but you don't have order, this app shell can lazy load that particular component behind the scenes for you. So if you're, for example, you can use many other techniques, one of which is guess.js. So if you want to predict where the user is going through the app, you can use that library, which uses machine learning and AI to detect the behavior of the user and preload those resources behind the scene for that particular user. And the source is Google Analytics, so it's fairly straightforward. But this is the power which comes with web components and this particular technique. So all of those apps are separate. So as we saw before, running separately, deploying separately, the collaboration is happening through the app shell. Now, if you go to the other one of the, for example, the React app, which is manual, and that's the important bit about it, I just have an index, which is my React component. It's basically, as you saw, it's got a template. Let me see where I can find the template. It's coming from this component. So this is the component, example component. It's got some props and a render method, which renders that HTML for you, which is fairly just a bunch of divs and the image. And then this index file is where the creation of web components from that component is happening. So this is like taking that React app, standardize it so it could be used in different browsers and different apps as a standard version. So React DOM exposes, for example, these two methods, render and unmount component at node, which then gives you, so you can use HTML to React, which is like a community solution in this instance. And all you need to do is create your component extended from the HTML element, which we saw before. So this is your custom element. You use the constructor. I'm just using a mutation observer for the updates to capture all the changes and re-rendering the component behind the scene. You can use the connected and disconnected callbacks to call React, for example, mount and unmount. And then from there it's fairly straightforward. So you just set props. If you happen to detect a change in your attributes, you just propagate that into your props into the React app. And here, this library, which I mentioned before, is basically acting as parsing that template changes and pass it to the React app. From there, you have the custom element defined with all the React element, which exposes that through web component. If you have a look at the Webpack config, which bundles everything together, it's just using Babel loader in this instance, which packages that web component to the main.js file, which you saw before. And I'm also adding an additional HTML file which consumes that. It's very similar to the app shell, but I needed to be able to run this particular web component standalone so I can test it before it gets merged to the main app. And if you have a look at the Angular app, on the other hand, this is a bit easier. I didn't use Angular elements here because that hides a bit of logic from you, so you get like some magic things happening which then exposes the web component. So you better understand how it works before using one of those libraries. All you have here is your app module, and then you basically define your module. You use this custom element component from the custom elements, which is this one. This is our custom element, which basically has the template. So it's fairly straightforward. It doesn't even have all of those crazy logic which React app had about prop changes and everything else to re-render the page. And then from there, you just do hook up to the ng-do bootstrap, which is called when the ng app is trying to bootstrap. And then you just inject, use the injector if you want to, for example, add any dependency or AI, use the DI from the Angular to inject any dependencies from there. And you create your custom element, pass it the element, pass it the injector, because remember that although you have a web component exposed, behind the scenes, still the Angular engine is running. So same as React. So all of those template changes, rendering changes, prop changes, all of those are handled still by the relevant app. So that's why in this instance, you have to inject the injector as well, because let's say you are injecting a service into your component, web components wouldn't know how to handle that situation. So you still have to use the Angular engine for it. And one of the reasons I mentioned before about being careful about using different technologies is this, because you're still relying on all of these frameworks. So your web component code includes some of this logic from the Angular engine. And the Webpack for Angular is pretty straightforward as well. If we have a look at this, it's just an app. You can specify what you want to expose, give it a path, etc., etc. If you want to have additional style sheets, you can also do that. Now, this demo was fairly simple. In a real-life scenario, you will have a bunch of problems, especially with the styling. So if each app is isolated, how do you make sure that they all reflect the same look and feel when it comes to the same? Because at the end of the day, user doesn't care what technology you use. User doesn't care what are you using, for example, for, I don't know, rendering your page, or how do you bundle your app, or is the app running separately, or do you deploy separately? User doesn't care. They just need to use the app. And the most important part for them is the UX and the experience which they have through look and feel and also interaction. So that's the most important part. So when it comes to those parts, all you need to do is make sure that the experience for them is basically the same. So you can use the same technique, you can use the same web components. Instead of having it for all those separate apps, you can break those apps down into smaller reusable components. So let's say you have a component library which contains, I don't know, input boxes, form examples. You've seen it in many different frameworks out there on GitHub. For example, when they have it for ng Bootstrap, or I don't know, React something. So all of those are trying to give you a set of a library of components which you can reuse, which gives the same look and feel whenever they use it. So every app, if they want to show an input, for example, a password input, they will have the same password input in all those places. So it wouldn't be different from any other ones, which also saves a bit of bundle size because the CSS is not repeated anymore. You're reusing the same CSS style sheets throughout the different apps. So if you want to have a look at some of the real-life use cases for web macro frontends, we come up to a bunch of very important ones. The very first one is if you want to migrate your current app into a different app, into a different framework, for example. So let's say you have a single app, you want to migrate it from React to Angular because you love Angular. In this instance, you have the two apps exposed as web components, but then you can gradually shift your features from the first app into the second app without breaking anything, so the user wouldn't be affected by all of these migrations. And at the end of the day, if you end up with all sort of components using just Angular, that's fine too. You don't need to use different frameworks because remember the bundle size problem. Fixing bugs, you can completely fix a bug in the React component as I showed you before. There is no other way to be dependent on the Angular app. That's a separate thing. So if fixing a bug in the search feature doesn't necessarily affect something in the Aspire team or in the order team. And then you can isolate those. For example, you can set integration tests for all of those to make sure that all of those web components work together. So your integration test basically is similar to having that app shell glue everything together, pass attributes to it, inspect what's happening, inspect the DOM. Very, very simple testing. It is basically makes your life very easier. And then you can reuse an entire app. So if you have a search mechanism which takes input, for example, and then gives you an output, which is an HTML template, you can reuse that whole web component in a completely different product. So not just reusing components inside the same app, you can reuse the app in multiple products. So all of those products look like they all belong to the same company in this instance. And when it comes to every refactoring, every change, not just in the front end, in the back end, it's this one. Taking balanced decisions is the secret to success. You need to be able to make these decisions in a balanced way. You can't say, I just want to have Vue, React, Angular, all of those, but then expect to have a good page size load if you haven't done it properly, if you're not doing lazy loading, if you're not careful about how do you propagate your styles, if you're not careful with shadow DOM and how do these components talk to each other. And also, at the same time, as I mentioned before, you wouldn't even need macro frontend if your app is fairly simple. Like this is for very complex enterprise applications we are here talking about. For normal applications, a monolith, a good monolith, a maintainable, readable code in the same monolith, works fine. You wouldn't even need to consider these techniques. How are we going with times? All right. So I was expecting to see everyone like this at the end. It didn't happen. I'm glad that you're all sitting upright. I know that you're very hungry for lunch, but time for any questions you might have. Do we have mic for all of these? I'll just act as mic.
How do you deal with stylings?
Yeah, so the question is, how do we deal with stylings? As I mentioned before, the best and elegant solution for styling is having component libraries and a master slide. So imagine all of those apps which are using their own styles. If a particular style is applicable to everything, let's say similar to Bootstrap. So if you have a container class which forces a certain style for the main container in the page, they all get it from the same style sheet. So you will have to share that style sheet for all the components, but they use build-time integration to basically bring those in and implement it. But then the trick is, how do we get in the build time, how do you make sure that that's not duplicated for all of those components? So you load one resource and then you load that resource inside each component, which you can easily do. Basically, let's say you wanted to call a backend service like an API, or you want to get a static resource to show it in a particular component. That call can be done in the life cycle of that component, even in the connected space, in the connected callback, or in the attribute change method. Similar to that, you can request the main style sheet when the component loads. So all of those styles are applied to the same components. They all look the same. But they also can have their differences because they might have different controls, which should look different in a sense. Does that answer your question? Yep. So the question is, what is the authentication workflow in a micro frontend world? As I mentioned before, everything comes down to app shell. So imagine that app shell is doing the authentication. It's getting the token from whatever identity server you're using. Any authentication flow would work. But then when it comes to all of those individual apps and how do they use, for example, if you're using role-based access control to show and hide stuff inside each app, the app shell is responsible to pass that information, that token, to those web components through attributes. So all of those get the same token, which they can then act upon. At some instances, you might have also separate authorization for each component. So you want to have the overall login, for example, but a particular app which should be only available for example, internal people, that can have a second level of authorization to see whether this person is internal or external. So it can have its own backend, which then does a second level authorization for that particular user, which is internal. So if you have an admin person sitting there watching a report, or even doing some, for example, config changes for a particular dealership in this instance, that can be handled by the admin app, for example. So you have your central login, which is, I don't know, people come in, log in by Google, or people come in, log in by your own identity server, whatever it is, Azure AD, anything, you can use anything. The fact is, how do you pass that information into those child or separate apps, which is, in this instance, is pretty straightforward. It's just attributes. You just pass an attribute, that component gets it, acts upon that particular attribute change. So the question is, what is the use case for a state management library? The most important part when we talk about state sharing between all of these components is you can definitely do that. You can use a state management library and then get, for example, a particular set of, or a particular subset of state, pass it as an attribute to a web component, right? The reality is, do you even need that? It all comes down to when we talk about isolated apps, all they need to worry about is their own state and what is to be exposed to another app. So you wouldn't even need a central state management because each app is managing their own state. They can use their state management internally, but at the end of the day, it's just input output. You wanted to keep it that way because if you go with, for example, the state management, then your integration test will be bloated because you have to take about all of those as well. So you want to keep it simple. Each component takes an input, gives an output. Regardless of how many times you do it, you get the same result, right? It's pure functions, basically, in a web component world.
If you want to build a library of small web components, but let's say you want to use React for each of those small components, do you need that wrapper logic each time? And how do you manage that?
Well, you will. Okay, the question is, if you want to use React for all these components, so let's say that you have multiple web components, they all are using React. The question is, do you even need to have the app shell? Well, at the end of the day, you will need one component which manages other components, right? So you can't say I don't have app shell, but I have a mothership component which manages that, which is again sort of like an app shell.
My question was more, if I want to do my own custom drop-downs, right, and then my own custom something else, etc. But I want to use React for all of those, and then wrap them in a web component.
Yeah.
It feels like there's a lot of boilerplate right now, or is there something to manage that?
It's okay. So the question is, in terms of smaller components like a input or like a combo box or I don't know, very smaller components. If you want to use React for these components, it gets bloated at some point. You have to basically repeat the same thing and the same thing again. My question to you was, if you have those small components, why do you need React for those? Because remember, the input, it's just that you can assign an event handler to it, change the input, see what happens. You wouldn't potentially need React for it. When we talk about reusable components, vanilla JavaScript will do. And that's basically 2 lines of code in normal JavaScript. You wouldn't need React for that. React is basically for more complex scenarios. If you want to have for example, if you want to have a custom element with a particular template, let's say you have a login form, you want to share it with other apps. So that makes sense. You have to use React, and then you can use a state management library like React Redux, for example, or Redux Forms to manage the form state on the client side and then sync it to server and do authentication, all sort of stuff. That makes sense to use React, for example. But for the smaller ones, it wouldn't probably make sense. So when we talk about component library, that's just purely JavaScript, CSS, HTML, nothing more, because you wouldn't need a giant engine to manage that particular event handler for you. Does that answer your question? Anything else? Pardon, I didn't hear your question.
How does this solution solve the performance issue that you had in previous examples and stuff like that?
So the question is, how does this solution, the macro frontend plus web component, solves the performance issue, the speed load, when we talk about page load speed? So most of the stuff is a trade-off when we talk about performance. So you gain some stuff, you lose some stuff. But in this instance, let's say you have a particular page with 3 components. They need to be loaded anyway, regardless of whether it's a monolith or a separate app, right? The only difference is when you use different technology, which makes the whole app a bit more bloated. So you get an app which consists of, for example, 3 different frameworks, and all those engines need to be loaded into the same app. So that's a bit of a trade-off. But at the same time, imagine that app shell, for example, can lazy load something. So if you have a quick example, like you have a really long page, your index page is really long, so it's a scrollable page. And you have a component which is hidden during the page load. App shell definitely can lazy load that and just load it when it comes to view. It's one of the samples when I have, when I talk about performance and lazy loading, especially for images. So if you have a page where the elements which are hidden, they're not visible at this point in time, you could lazy load them later when the user starts to scroll. So that's one of the examples. The other example is when you talk about routes and navigation, if you were going from page 1 to page 2, and page 2 is using a different component, for example, page 1 can still lazy load that particular component, so it's just ready when the user navigates into the second page. That's another benefit in terms of performance. But at the end of the day, as I mentioned before, the fact that you can use a different framework, it doesn't mean that you should use a different framework. It's just that how do you manage this balanced decision you want to make? Every team can have their own stuff, but if all the teams are using Angular, you just load the engine once. You don't load the engine multiple times for each component, which basically makes everything smaller. But if, for example, an app is used in multiple products, it probably makes sense to allow them to use their own tech stack, because they might have a different app which is using React, and this component is written in React, so that particular product is faster. It comes to priorities and how do you manage those decisions. Anything else? All right. It's been an honor to present this topic to you. I hope that this has been motivating enough. Go and poke around with this. There are heaps of resources which I share shortly on Twitter, and also on a short blog post about all of these. If you want to, sorry.
The examples you showed, will they be on that?
Yes, that will be in the GitHub repo which I've created previously. You can go through the source code. I'll put the slides up there too. And the other thing is, there are multiple really good resources about micro frontend. There are blog posts on Marty Fowler's website, which got published 3 weeks ago or 2 weeks ago. There is a microfrontend.org website, which basically has the whole app written in multiple ways, including the web components. And they talk about, they haven't got to the point where they talk about styling, but they also talk about a bunch of stuff that I couldn't fit in this short session. So explore those options and make sure that you basically tackle this problem if your problem is complex. You wouldn't need to spend heaps of hours on implementing something which is not going to be used anyway. So definitely, my advice, just be smart, as you are now. And enjoy the lunch. Thanks for coming.